At Rea, our formula is simple: improve, develop, and grow. Our Fort Wayne plant has a rich history as a world-class manufacturing facility, producing magnet wire or winding wire in every size and shape, from the simplest bare copper to the most intricate continuously transposed cable. Along with enameled, taped and Dacron glass-covered wire, transformer lead cable, and multi-conductor, we produce over 500 different custom products every year, each one built to exceed the standards of our customers. Great magnet wire begins with great copper rod, and our process begins on our docks, where we receive hundreds of tons every week. The copper rod is broken down or resized to bare wire stock through either an extrusion or rolling process in our wire mills. The bare wire is then sent to our other manufacturing centers for additional fabrication through an enameling, wrapping, or taping process. Our Fort Wayne plant also houses our Transformer Center of Excellence, a state-of-the-art clean room production facility complete with a particulate monitoring system critical to meeting the rigorous standards required by our customers. No one matches our product breadth, the depth of our experience, or our exacting production standards. Throughout the manufacturing process, Rea's integrated management and quality process system, Rea IQ, tracks thousands of data points for continuous real-time monitoring. Every finished product undergoes thorough lab testing to make sure that it exceeds standards for quality and matches the customer specification prior to shipment. Finally, automated business transactions processes ensure your order is packaged, scaled, and ready to ship. The Fort Wayne plant is just one example of Rea's commitment to meeting the needs of an ever-changing marketplace. Rea Magnet Wire, powering progress.
I also wanted to provide you a little bit of a history lesson on our facility here in Fort Wayne. So I pulled out the Rea history book to look up a few facts and figures. So if you didn't know, George Jacobs back in 1911 started a business in Fort Wayne known as Dudlow Company, which eventually grew to be one of the largest magnet wire manufacturers in the country. And Dudlow magnet wire really was essential to the production of the Model T. And if you didn't know this, Victor Rea was a foreman in Dudlow's coil winding department. So Victor Rea is who we are named after. So very interesting fact. Then eventually what happened when we got into the Great Depression, the Dudlow Company was eventually sold off, or it was merged into General Cable. And George Jacobs spun out and started a new company known as Inca Manufacturing. So what's interesting, I'm standing here today in front of the building, and right here is the symbol that's outside of all the doors in this facility that symbolizes Inca Manufacturing. Very interesting piece of history. And eventually Inca was sold to Phelps Dodge, and as you know, more recent history, Rea Magnet Wire purchased the magnet wire operations of Phelps Dodge here in Fort Wayne back in 2006. So there you go, there's approximately 100 years worth of history in 2 minutes.
Hi, I'm Connor Ruby. I'm a development engineer from Rea Magnet Wire, and today I'm going to show you how to put together a magnetic motor kit by Simply Science. Let's get started. Let's start by unboxing the components. Inside, you'll find a coil of magnet wire, two metal supports, a battery, a plastic battery housing, and a magnet. To start with, we'll want to take our coil of magnet wire and ensure it's roughly the same diameter as battery. Since mine's already coiled, roughly the same size as the battery, I'll continue from here. First, let's straighten out 2 inches of magnet wire from each end of the coil. A good gauge here is the length of a D-cell battery is approximately 2 inches, so as long as you have the same length of wire protruding from the coil, that'll be plenty for our exercise today. Once you have a couple inches of wire protruding from each side of the coil, go ahead and wrap it around the main coil a couple times just to hold everything together. I'll do the same thing on the other side. At this point, we'll have a coil of magnet wire with 2 legs of equal distance protruding out of each side. And now I'm going to remove the enamel insulation from one side of the wire. To do this, you'll take the coil, hold it vertically, and place it on a flat surface. Use one of the metal strips or supports to strip the enamel coating from the surface of the wire. It's critical here that you only strip the insulation from one side of the wire. I'll demonstrate now. Now notice I didn't flip the coil over. You only want to strip the insulation from one side. Now I'm going to flip the coil end for end and do the same thing on the other side. Again, remembering to only strip the insulation from one side of the wire. So now you have a coil of magnet wire with 2 leads with the enamel insulation removed from one side only. At this point, we can assemble the rest of the motor. We'll start with these metal supports. It's important at this step to make sure this bump on the support is facing in towards the battery. I'll repeat the same step on the other side. Again, the bump in the metal support needs to face in towards the battery. Once both metal supports are installed, we can install the battery. Now we can place this on a flat surface and install the magnet. Once the magnet's installed, we're ready for the final step, which is installing the coil and seeing what happens. The motor works because electricity runs through the coil wire and a magnetic field is formed. The magnetic field only forms when the bare wire touches the metal supports. You can feel this by holding the coil in place with the shiny sides down against the metal support. The coil pushes away from the ceramic magnet with enough force to turn it all the way around. As the coil turns around, it becomes charged again and gets another push. This process happens again and again to keep the motor running. Have fun building your motors.